The purpose of today's presentation is to cover some aspects of the Local Road Safety Project Development Program initiated by FDOT District 4. Specifically, this presentation is going to cover some of the technical aspects that go into the analysis and vetting of proposed projects. A brief overview of the proposed schedule for District 4's Local Road Safety Program in coordination with MPO, TPO, and local agencies. The schedule is going to basically follow the local agency list of priority projects schedule that is submitted to the MPO. You can see a snapshot here, and more detail will be discussed at the workshop in July. So specific to today's presentation, I'm going to cover some aspects at a high level of what would be expected in the safety study and the components thereof in order to fully review, develop, and vet a proposed project. I want to emphasize that some of these components may require more detail or less detail depending on the particular project, but this is intended to give a high overview of what is expected and what could go into the thought process of developing a safety improvement for the local roadway. Safety analysis starts with crash data analysis. There are some key guidelines here that will help make sure that the crash analysis is comprehensive and thoroughly reviewed. First, using Signal 4 analytics, download all crash data within the study limits. The bullet here says cast a wide net. What that means is don't just limit a polygon selection to the close confines of the intersection. Often crashes are coded outside of the influence area or miscoded. So draw a slightly bigger net or polygon when you're querying the crashes than your actual review area. 5 or more years is required. 2016 to 2022 is the preferred 5. Those are the most recent official or confirmed crash data years. It is also recommended to supplement with 2021 and 2022 data in order to review and verify trends that may have continued or may have even been exacerbated over the recent years of crashes. And it's understood that 21 and 22 data are not certified as complete and may be subject to change. When doing the crash analysis review, it's important to manually review the police reports. Again, as I mentioned, often crashes can get miscoded. So when you're looking at the police report, is in particular the narrative and the drawing at the back of the police report, you want to verify as best as you can the location of the crash type, and any other contributing circumstances from the narrative. Once you've quality controlled, reviewed, and modified the crash data tables exported from Signal 4 with updates based on the police report review, you'll want to tabulate the crashes in order to create a synopsis of the crash patterns. To the right of the text is an example of a crash data summary, which shows crash type, injury severity, lighting condition, surface condition for a particular crash area. This can be modified as necessary for different factors, but this serves as a good example of what you'd want to see. This helps highlight and review the particular crash issues of concern. Next, in order to create a visual representation of the area, you would develop a collision diagram. The collision diagram is an extremely useful tool as it'll show the year of the crash, the type of the crash, the location of the crash, is color coded by severity. For instance, red would indicate a fatal crash, orange would indicate a severe injury crash. You can also tag other factors such as whether the crash occurred during day, night, or wet, dry conditions, etc. It's a very helpful tool to give a graphical representation of the crash problems or potential crash problems within your study area. When doing the crash data analysis, in that table we mentioned previously, you want to identify the key patterns of focus. For instance, is it eastbound left turning crashes at a signal that are causing the problem? Is there a predominant or overrepresentation of nighttime crashes? Pet bike crashes, are they at the intersection? Are they mid-block? Are they bicyclists riding along the road, etc.? And as you're going through these preliminary crash reviews and detailed crash verification, this is a key time to start brainstorming the countermeasures that could potentially be implemented to solve the crash problem. This will help in the next phase of going out in the field and reviewing the existing conditions. When conducting the field review, it's important to consider when the field review is going to occur. You could do the field review during a period if you see perhaps a significant spike in crashes during the PM peak rush hour. If your crash issue is predominantly nighttime, you would want your field review to focus on the nighttime dark conditions, etc. High traffic volumes, high activity. If it's a high ped bike corridor, when are those users using the road most frequently? When in the field, there are numerous things to observe, and checklists can be provided that will help guide, but aren't a end-all be-all for what to review. But you'll want to observe the behavior of users. This is all users of the roadway, vehicles, pedestrians, bicyclists, buses. The traffic characteristics. Is there a predominance of speeding? Is there distracted drivers? And it's obvious that they're throughout the corridor. At turning lanes, are there significant queues that are causing spillback that may result in problems? Are we seeing failures at traffic signals? For instance, it's taken 2 to 3 cycles to get through and resulting in impatient drivers. These are just a few things that you would observe in traffic characteristics, but watching everything operate in the field is critical. You additionally want to look at geometrics, the opportunities and obstacles for some of the preliminary improvements that have been identified. Are there right-of-way concerns? Are there utility concerns, sight distance obstructions, etc.? Paying close attention to the geometrics for not only what could be changed to mitigate crash problems, but also what could be obstacles to potential solutions to those crash problems. Now that the crash data analysis has been done, some preliminary ideas have been brought forth, and the field review has been conducted, the next step is to actually develop the proposed countermeasures for the specific location based on what has been observed. It's key to say, does the solution solve the problem? Looking at the crash patterns, the behavior in the field, what is the most suitable set of options that could actually mitigate the crash problem or behavioral problems that are being observed in the field and demonstrated through crash data. Based on the field review, looking at aerials, etc., are there any constructability issues related to the proposed improvements? Again, mentioned on the previous slide, and will be mentioned again later because it's extremely important. Things like right-of-way, landscaping, potential utility conflicts, these all need to be considered when selecting the countermeasure, because if significant obstacles present themselves later, it could derail the project and we start again from square one. I want to emphasize to focus on best value. Often the most grandiose solution might not have significantly more benefit than a more modest solution. So make sure that the solution and the magnitude of it are consistent with the crash problem you have, and consider things that may be a step back that could have a similar or equal mitigation impact to the crash problem or behavioral problems you're observing. For instance, is a traffic signal installation the best solution to a crash problem, or are there geometric changes, signage enhancements, etc., that could address the problem almost in the same manner or very similar to the same manner? So consider that when selecting your countermeasures. Once the countermeasures are selected, the crash problems are identified, the field review has been done, and this could be a process that's done throughout the life cycle of the project development, but making sure we get stakeholder coordination complete within this process. The key to this is you don't want to get the project all the way through the process and then find out that you do not have support from various stakeholders. So a few are listed here. The maintaining agency. Is the maintaining agency presumed to be a local agency? Are they willing to and do they have the ability to maintain the project? I keep using a traffic signal because it's an easy example, but if the request were for a traffic signal installation, can the maintaining agency maintain any issues with that signal in the future after it's implemented, after it's constructed? Elected officials. This can sometimes serve as a roadblock. You want to make sure the elected officials support the project and consider presenting at one of the council or committee meetings. Again, you don't want to get all the way through the project development process and find out there are citizen, neighbor, or elected official objections to the project, and thus the project might get removed from consideration due to that pushback. And again, in concert with elected officials, nearby residents, and businesses. Explain the project to them, work on consensus building, consider having workshops to go through the project and understand any concerns that the residents, businesses, neighbors may have. A good example of this would be if a project were proposed to install a raised median between a 4-lane road with a 2-way left turn lane. You could get this project all the way through most of project development and find out that the adjacent businesses are going to push back because they're losing their direct access, and their access to their businesses is turning into right in, right out, for instance. So you want to make sure the coordination is done early to get buy-in from all stakeholders of the project, particularly the 3 that are bulleted here. Through the process, feasibility is critical. You've identified a crash concern. You've identified a very good project that could mitigate it. You have buy-in. Now it's making sure we can actually build the thing. So the way to go through feasibility evaluation is to develop a set of concept plans, and the general level of detail of a plan is shown here on the right, which was median modifications in Young's circle. And once you've got the concepts developed, looking at the potential issues almost at a 30% design phase. Are there potential right-of-way impacts? Are there utility impacts that could be considered? Trees and landscaping issues, issues with a nearby oak tree or something to that effect. Will the project cause site obstructions or site distance obstructions? And in general, is the project constructible and, constructible in a fiscally responsible way? So reviewing all of these things through the evaluation process is critical because we don't want to get down the road again. All of this is designed to avoid issues with the project as the later phases go. So making sure that the project is constructible, we've vetted any issues, we've at least identified and documented potential issues so that ways to mitigate those issues can be discussed and reviewed as we go through the project review cycle. At this point, it's time for the project cost estimate. This is a very critical piece of the process, and often one that doesn't get the level of attention that it truly needs in order to vet the project. The level of detail is an engineer's estimate, which means an itemized pay item list to the best of an engineer's ability to cover all quantities associated with the project, pavement quantities, signal quantities, signing quantities, etc. Should be prepared by or thoroughly reviewed by a professional engineer. Again, detailed pay items. And since the projects are typically going to be LAP projects, FDOT costs, not local agency costs, should be used. And you can easily Google FDOT historical costs to get the recent 6-month averages within your county or the district. It's also important to include the non-construction items within the cost estimate because there's many aspects to, the full funding amount that will go in, and also to acknowledge the responsible party for those different components, whether it be the local agency or FDOT. So several things that need to be considered are the preliminary engineering or design, CEI, maintenance of traffic mobilization, post-design services, is subsurface utility needed, is survey needed, etc. All of these need to be considered when you're developing the detailed cost estimate in order to have a conservative but also well-refined cost estimate as you move forward into the financial analysis, as well as requesting the funding. At this stage, conducting the crash reduction estimate is obviously a very critical piece, and this can probably be done as soon as you've selected the countermeasure prior to the cost estimation and concepts, but it is a critical piece to the overall analysis. The step is to identify a crash modification or crash reduction factor that applies to the problem or issue that is being observed. Those can be found on the Crash Modification Factors Clearinghouse, the Highway Safety Manual. In the absence of those having resources, there are other FDOT or federal sources that can be used to identify crash reduction factors. And lastly, engineering judgment. And this should be a last resort after attempting to find documented acceptable crash reduction factors for the particular mitigation factor. Apply the crash reduction to the appropriate crash pattern. This is important. Many crash reduction factors focus on a particular type of crash or severity of crash, etc. So make sure you review the documentation and you apply the crash reduction or crash modification factors appropriately to the crash pattern that is documented for mitigation. During this review of crash reduction, at the end, you will have estimated the crash reduction in reduction of crashes per year by crash severity. Most typically, you would say it would demonstrate a reduction in X fatal per year, X severe per year, and X other injury crashes per year. It's important to note that there are many ways to review if multiple countermeasures are proposed. If this situation arises, it's important to select an appropriate method. So if the project that is being proposed does require the evaluation of multiple countermeasures, please reach out to the district for information and discussion on how best to apply that across the crash data. We have the cost estimate, we have the reduction in crashes, we have stakeholder buy-in. Now we have to do the financial analysis. The benefit, cost, and net present value. Generally, this takes the crashes that are being reduced per year, the life cycle of the project, how long is it going to last, the construction time of the project from beginning to end, making sure to include all of the costs we discussed earlier to get the full representation of the cost of the project. And through this, and through various worksheets which can be provided by the district, you will calculate the benefit cost analysis and the net present value, which will be used in the evaluation and prioritization of the projects that are submitted. All components of the safety analysis, safety study should be documented in a technical memorandum or a safety study report, depending on the magnitude of the improvements and how much documentation is required. This document should be prepared by or with the oversight of a professional engineer, summarize all the steps that we discussed before, as well as any additional steps that are taken or any other items that the engineer agency submitter chooses to document. Include exhibits, pictures, and any supporting documentation that it is felt would help with the vetting, review, and prioritization of this project. And it's important to note that FDOT will conduct a detailed review to confirm all assumptions. So exercise diligence so there isn't a lot of back and forth on responses, comments, reviews, etc. Taking the time to really be thorough in this analysis will help expedite the reviews once the study is in FDOT's hand. Once the projects are submitted, FDOT District 4 will go through a review and selection process. This will be discussed in more detail again at the workshop in July, but a few key things to note. In order to be eligible for safety funding, it is desirable to have a benefit cost ratio greater than 2. Anything greater than 1 demonstrates a benefit to the project, but it is desirable to go greater than 2 in order to really significantly demonstrate the project's benefits. There will be a focus on fatal and incapacitating injury reduction. The Highway Safety Improvement Program guidelines focus on this, as well do all initiatives you're familiar with, like Vision Zero, Target Zero, etc. The intent of safety improvements, or the focus of safety improvements, is really to drive down fatal and incap. Obviously, we want to reduce all crashes, but focusing on those that really have an impact on life are what we want to look at. A part of the prioritization criteria will be the net present value, the value of the project through the future. which we discussed calculation previously. The district will also review projects that are addressing the vital few emphasis areas, which include lane departure crashes, pedestrian bicycle crashes, intersection crashes. So please review the Strategic Highway Safety Plan for Florida. And if your project is applicable to one of the vital few emphasis areas or the strategic emphasis areas, please indicate that, as it will be taken into the project prioritization process. Once all the projects are reviewed, FDOT staff will meet, discuss, and conclude which projects may move forward for funding application. So it's a detailed process, and we look forward to working with you all. We will provide much more detail and be able to answer questions at the workshop in July, so we hope you can attend. In the meantime, if you have any additional questions, please reach out to the FDOT District 4 Safety Office for additional information. Thank you very much.